Assalamualaikum. My name is Kiasatina binti Mohamad Khairi, 2020-49-49-46 from EC1101 F1 class.
Hi, my name is Nur Shuhaszira binti Ahmad Fazin, ID number 2070606654 from group PEC 110 F2.
Hi, I am Umie Maisarah binti Abidin, 200457-124 from class PEC 1101. What is integration?
Integration is a reverse of differentiation. It is actually a method to find a function gs, the derivative of which dgs is equal to a given function fs. This can be implied by the integral sign, as in fs is generally called the indefinite integral of the function. The symbol dx represents an infinitesimal displacement along x. To conclude, fsds is the summation of the product of fs and dx. The definite integral is written as below, where a and b is called the limits of integration, which is equal to gb minus ga, where dgs equals to fx.
Why do we use integration? We need to use integration because we have curved sides, so we can no longer use simple formulas. Along with differentiation, integration is the basic operation of calculus and serves as a tool for solving problems in mathematics and physics involving areas of arbitrary shapes, lengths of curves, and volumes, among others. The integration referred to here is the so-called integral, which can be formally interpreted as an area sign in the region in a field bounded by a graph of a specific function between 2 points in a real line. Integral can also refer to the concept of antiderivative, a function whose derivative is a given function. In this case, they are called indefinite integrals. The basic theorem of calculus connects exact integral with differentiation and provides a method for calculating definite integral function when its antiderivative is known. Problem statement. Problem solution.
Determine the area, the region R then enclosed by the curve of y equal to x squared and line y equal to 1. Now, we can see what this region looks like. What we can see that you have one curve which is divided into the two parts, namely A1 and A2. This curve touch a y and x axis that we call y equal to x squared. Straight line touch the y-intercept, we can see that this line y equal to 1 and x equal to 0 for this line. 0 is the coordinate for C and 1 is coordinate for D. What we are trying to do is find the area, the space trapped between this curve over the interval from the 0 to 1. We will look from right to left to calculate area A2 and A1. We use the solution is CY equal to x left minus x left. Y equal to x squared is the view Fy for A2 and x equal to 0 is the view for Fy to A1. To get the total area, we need to add the number A1 and A2. Then we get the answer for total A area.
Determine the area of region R that enclosed by the curve of y equals to x squared and line y equals to 1. What I can say is, we need to find a solution for this. First of all, I need to find the area of A1. A1 equals to integrate c to d cy dy. I take cy from the previous explanation. This is from up here. As you can see, this is a negative symbol. But why? Here I put a negative symbol because this point is in the negative quadrant. For the square root y, here's the explanation. Shown in the diagram that y is equal to x squared. So, square root y is equal to x. Negative and negative becomes positive. Just cross the 0. Square root y becomes like this, because square root is just the same with the power of 1 over 2. When we integrate, we must add 1 to the power, and also divide by the new power. For this part, we will break it like this. 0 power of anything will always equal to 0, and down here, 0 divided by anything will also always equal to 0. So if there's calculation like this, take it easy, no need to calculate anymore, just write 0. For your information, 1 power of anything will always equals to 1. So 1 power of 3 over 2 equals to 1. I got 1 divide 3 over 2. And the final answer for E1 is 2 over 3.
The next step is we search for the area of 2. Okay. E2 is equal to the integrate 0 to 1 bracket y minus 0 dy. Since it is integration towards dy, so we have to search for x, and we got square root of y. So after this, it becomes square root y dy. Change it to bracket, and we got y, and we got 3 over 2. So how we got 3 over 2 is because we changed the power, and we got 1 over 2, and we plus by 1, and we got 3 over 2. After that, we divide by the power, and from 0 to 1. After that, we bring 2 to the up and divide by 3. 0 to 1. We substitute 1 into y, 3 over 2 by 3 minus 0. Since when we substitute 0 into y, 2 times 0, so everything will come 0. We just put 0 here. And then we got 2 times 1 over 3, and we got 2 over 3 as the answer. So the last step to search the whole area is we added area 1 and area 2. From the previous video, A1 we got answer is 2 over 3, and for this also we got 2 over 3, and when we add up, it becomes 4 over 3. The unit is unit per square. So the area for this graph is 4 over 3 unit square.
Conclusion.
For the conclusion, based on what we have learned after complete the test, we have seen how integration can be used to find an area between a curve and the x-axis. We can solve the problem related to the cross-section parallel to the x-axis. In each case, we see if we are talking about an interval where fy is greater than gy, the area between the curve is just the defined integral over the interval of fy minus gy dy. To obtain the total area, need to add the area A1 and A2. The area also can be found by using cross-section parallel to y-axis. In the simplest of case, the idea is quite easy to understand.
Reference. We also refer to a book titled Calculus 1 from UiTM Pulau Pinang. Applications used for editing. Music used in video. That's all from us. Thank you. And salam UiTM di hatiku.